Welcome back to the Pool Pro Podcast. Master Water Specialist Greg Reyneke talks about all things ozone, including effectiveness and the best way to use it. Plus, he provides his thoughts on pool owners saying they are allergic to chlorine. I know I say you don't want to miss this episode a lot, but you really don't want to miss this episode. Welcome back to the Pool Pro Podcast. This is Michelle Cavanaugh with my co-host,
Dave Rockwell.
Hey, Dave. I'm excited to have a master water specialist with us today. And if those of you who do not know what that is, stay tuned because it's going to be a great conversation from Greg Reyneke, and it's going to be about ozone today, I believe. And Dave is an expert in that area, so I'm excited to hear this conversation. Welcome, Greg.
Thank you very much. It's a pleasure to be with you both.
Pleasure to have you. So let's talk about your background. How does one become a master water specialist?
So I've been in the water business for almost 30 years now. I grew up, my weird accent's from South Africa. So I grew up in South Africa, qualified as an electrical engineer, moved to America and realized that my passion was with water. So I've been in the water business for a very long time. So a master water specialist is a designation given by the Water Quality Association for people that have attained sufficient schooling and experience to have knowledge on water quality management issues, from drinking water purification to disinfection, reverse osmosis, deionization, distillation, system sizing, design, deployment, and troubleshooting. So my background and experience in water, I'm a water guy, I'm not a pool guy, but all the water issues that we deal with as water people transcend the industries. So I've done a lot of aquatic ecosystems for aquaculture, a lot of big commercial pools, and usually someone of my skill set gets involved when things go wrong. So usually if there's a problem or if something doesn't quite work as advertised, then it's time to look at the water chemistry and the interaction between the treatment methods and what's going on and trying to figure out how to do it better.
Nice.
And I think it's more and more critical nowadays. We've had a lot of conversations on the podcast already about the quality of our pool fill water, the quality of tap water and well water coming into the pool. And another point that came up a couple of weeks ago was that the Europeans look at their pool water in terms of drinking water standards. We tend to look at our pool water like bath water standards.
Yeah, that's exactly right. And it's time we harmonized it. You know, pool people are very smart, and there's nothing stopping pool people from understanding more about water quality and how to manage it better.
And there is so much more than just chlorine chemistry, chloramines. There's all kinds of pollutants in our drinking water nowadays. What was it? Houston just had the brain-eating amoeba outbreak.
Yeah.
We're finding that, biofilms in the pipes, the way that they're treating water, may not be all that effective. All of these things end up downstream in our pool. And so these are things that we don't have a test kit for it, but it's things we have to think about and account for.
And a big responsibility as pool people, it's not just having clean, clear water, it's having safe water. If you think about it, according to the CDC, recreational waters are one of the top 4 places where people can pick up Legionella.
Yep.
And 10% of people who get Legionella die.
Yep.
So that's more deadly than the COVID, but we don't react to Legionella the way that we have to other issues. And so it's a big responsibility. It's a solemn responsibility to take care of recreational water.
Yes.
Yeah. So we started talking a little bit about ozone. Ozone is one of my favorite tools for treating pool water. And so from your experience, why don't you kind of tell us a little bit about how you use ozone and what you can just tell us what you can about it.
You bet. So ozone is a really, really powerful tool, and ozone is something that nature creates all the time. So if we get a little geeky and chemical about it, ozone's chemical symbol is O3. It's triatomic oxygen. There's 3 oxygen molecules. And triatomic oxygen is highly unstable. And that's a good thing for what we're using it for, because it's so unstable, it wants to attach to anything and everything it can, which means it rips apart organics. And so a great place to use ozone in the recreational water space is a way of helping to knock down your total organic load in the water and do some of the heavy lifting when it comes to clarification and disinfection. So that highly unstable ozone, when it's injected into the water, it immediately reacts with anything that it can oxidize, whether it is dissolved iron, dissolved manganese, if it's any kind of biomass. If you think about when you get a cut and you pour peroxide on that cut and it foams up all white, that's the peroxide, which essentially is stabilized ozone, reacting with the amino acids in the cut. And it's a violent reaction. And so when we look at what's going on with that pool water, if we dose enough ozone, and we can control for the temperature of the water, and we can control for a few other things, we end up with water that requires less chlorine to stay sanitary, generates less disinfection byproducts, which means less sore eyes, which means less hair damage, which means less skin irritation, and less latent odors, trihalomethanes, things like that. So ozone, when used right, is a very powerful adjunct to traditional pool water treatment. The key is using it right.
Right.
And that's probably one of the places where I see too many people probably not knowing what they don't know, which is our biggest issue in life, right? We just don't know what we don't know. And so you go in, you might buy an ozone generator from a catalog, and it's a little teeny tiny little box about yay big, and you install it on a 10,000 gallon pool, and you wonder why nothing good happened. And that's probably one of the most common things. The next most common thing is not understanding how ozone works and how to preserve ozone treatment equipment. And so ozone's great, but you got to learn a little before you do.
And you hit on a big thing. I've been working with ozone in swimming pools for 20 plus years now, and I'm a big fan, but I've seen ozone come and go in terms of its popularity among pool professionals, and it's for the reason you just described. They buy a little light bulb in a box and stick it on there, and it's making less than a gram of ozone. And so they just throw up their hands and say ozone doesn't work because they saw no results in the pool.
Yep.
Ozone works. The ozone that thing was making was working, but it's like putting a teaspoon of chlorine in a 20,000 gallon pool, right. Nothing happens, and saying chlorine doesn't work.
Exactly. Couldn't have said it better. Your fire doesn't work because you try to heat a room with a candle. You know, it's one of those things, and then not maintaining the systems properly. So as a professional, you've used ozone for a very long time.
Right.
You learn really fast. You know, there's really 2 ways you can generate ozone. One is with 185 nanometer ultraviolet, and then the other is with what's called cold corona discharge, or dry ozone, where you use electricity to break up and destabilize oxygen.
Yeah.
Where everybody makes a mistake is they start with a UV system because they're told UVs are pretty indestructible and they can't break and they're not affected by humidity, but then they're injecting such small amounts of ozone, it does nothing. So all they did was waste their money and by extension their clients' money. And then when they graduate up to corona discharge, they usually end up putting it in a moist area or in a vault that's got high humidity, and they end up with nitric acid issues, and they end up with a poor quality of ozone. So if you're going to do ozone, you got to look at really ozone as a holistic, and there's 3 parts to it. The first is how much do you need to generate? The second is how do you prepare and pre-feed for the ozone? And then the third is where do you put it? You know, how are you going to put it into your circulation system? How are you going to guarantee that you mix it right? You know, there's a lot of little details that you want to make sure you take care of. And thankfully, there's a lot of good training and education out there There's a lot of people that want you to succeed, but make sure you research a little bit before you just go throw something on a pool.
Well, and that's where I think the manufacturers of ozone systems, the smaller ones, have really done themselves and the industry a disservice by they don't say what the output or the concentration of ozone is. They just say, well, size this unit for 20,000 gallons or this unit for, and they're basically units I might maybe put on an aquarium. They're way overestimating the amount of water that their units can treat. There's when it comes to sizing and dosing ozone, there's the way that it's made, the UV or corona discharge, but there's also the air prep, the way that it's treated. Can you maybe talk a little bit about that?
You bet. So there's a few things that will affect the quality and strength or concentration of the ozone that's generated. The first is how dry the air is. So if we think about ozone generation using corona discharge, we're basically creating lightning in a bottle. We're using a high voltage transformer, and think of it like a little taser. It's zapping little electric charges across between the anode and the cathode in the chamber, and that is causing the destabilization of the oxygen. And so we want a very dry air. So one of the first things to look for with your ozone generation is what ambient humidity are you going to be in? And California in particular is a place where humidities can swing. You know, if you're on Central Coast, you might be 30% humidity in the afternoon, but then tomorrow morning you might be up around 80%. And so you've always got to look at worst case for your humidity and then deal with it accordingly. So the most common thing that good practitioners will do is install what's called an air dryer. And air dryers come really in two flavors. The one is sacrificial, where it uses a silica gel. Those little packets that they tell you not to eat that come with everything, that's silica gel.
Don't eat it.
Don't eat it. It's hygroscopic. It absorbs moisture into the little beads. And those beads can be regenerated. You can actually cook them in the oven at a very low temperature and drive out the moisture. And then you have other air dryers that have it all automatic and built in, where the air dryer dries the air, and then it has a heating element that then dries the air dryer. But you got to look at your ambient humidity, number one, and then deal with your manufacturer on making sure that you have sufficiently dry air 24/7. What happens when you generate ozone using corona discharge is if you have any moisture in the air, that moisture is going to combine with nitrogen in the atmosphere, and it's going to create nitric acid as one of the byproducts. So that nitric acid will then chew holes in your corona cell, and then it ends up interfering with your discharge tubing down the line. So there's your first thing, good air prep. Number two, what kind of air quality are you going to put in? So we think about the atmosphere. Our atmosphere isn't all oxygen. We've got carbon dioxide, we've got nitrogen, argon, helium, we've got all these gases in our atmosphere. Oxygen's a very small part of that. So the next thing that's most commonly done is to use what's called an oxygen concentrator. And an oxygen concentrator removes nitrogen from the air that is being run into the ozone generator. By raising the oxygen concentration, you then raise the ozone output. And it's exponential. I mean, oxygen concentrators cost money, air dryers cost money, but you go from a candle to a roaring fire when it comes to oxidative capability. When you get on the really high-powered stuff, we actually would use liquid oxygen feed. For most pool pros, that's something I would steer you against because there's a lot of liability there. So stay up until ozone concentrations where you just use an oxygen concentrator. The next thing is getting the ozone to where it needs to go. And the first mistake a lot of people make is they use vinyl tubing. And vinyl tubing, just like vinyl cracks in the sun, vinyl reacts with ozone. And so your little ozone generator is cranking out ozone as hard and as fast as it possibly can. And then you use vinyl tubing from the ozone generator to your discharge point. You actually end up using up a lot of your ozone in the tubing. The ozone destroys the tubing, and then the tubing gets brittle and cracks. So when you're purchasing an ozone device, make sure you discuss that with your vendor, that you're looking for ozone resistant tubing. For the applications we work with, we typically will use Kynar. There's a number of tubings that have different levels of ozone inertness. Because remember, ozone attacks everything it touches. It's like a little Tasmanian devil. It just bounces around and just attacks. And so we've got to try and steer its destructive energy to where it's good for us. And that brings us to the final point, is getting it to where it needs to go. So ozone, when we use it for water treatment, ozone has almost no residual disinfecting capacity or oxidizing capacity. It's highly unstable, it reacts, and it's gone. And so it's really important that we look at putting it to where it will do the most good for us. And so the most common way people will do that is putting it on the recirc circuit and using a static mixer and or a contact tank to make sure that you're getting as much mass action, as much contact between the ozone, the water, and what's in the water as quickly as possible. Because there's one really ugly complicating factor with ozone, and this is particularly important with pools. Ozone lasts long when it's cold. Ozone disappears very quickly when it's warm. In 70-degree water, you've got less than a second for that ozone to get its job done. And this is something that a lot of vendors conveniently overlook when they're supplying ozone equipment to pool professionals. Most pools are not that cold. Whether it's warm climate or you warming it in a cold climate, we're typically running a very nice, comfortable bathing temperature, which is not very conducive to ozone. So we have to overcome those temperature limitations.
So the bubble size has a lot to do with it. The way that you dissolve the ozone into the pool. There's some of the really small systems actually have you connect it to the winterizing plug on the vacuum side of the pump, and that's how they pull the ozone into the system.
I would respectfully discourage anybody from doing that ever, because ozone eats seals.
Yeah.
And we don't like pumps to cavitate. And so inducing gas into the intake suction side of the pump, you're creating cavitation and you're chewing up your reactive surfaces. Yeah, no, let's not do that, kids.
What I've always told people about that is if you're not making enough ozone to destroy your pump seals within a month, you're not making enough ozone to do any good in the pool.
I agree 100%. That's exactly right. So the best way to get it in there is to use either an injection quill with a static mixer or a Mazzy injector, a Venturi style injector, where you're breaking those bubbles up so that they're as tiny as possible, because you want that instant mass transfer. You want it to mix as quickly as possible.
And the smaller the bubbles, the longer they last. There's also the more surface area that the ozone has to come in contact with.
That's exactly right. Yep, that's exactly right.
You're dissolving a gas into the water, which gas doesn't want to be dissolved in water by nature, and so the way to get the most out of it. Now, what I have found with using Mazzy injectors and the right size ozone system, what I consider the right size ozone is quite large. But I actually do get measurable ozone in the pool and coming back from the pool. I put an ORP reader on the pool, and it's very possible to get 700-800 ORP in the water coming back from the pool, which tells me I do have dissolved ozone in the water.
And there's a good thing to segue into there, Dave, is ORP. You know, the oxidative reductive potential of the water is a great way to see how you're doing on disinfection. And I wish more pool professionals would utilize ORP controls. You know, you can use ORP as a fantastic guide to see how you're doing with the quality of the water when it comes to the survivability of bugs. Bugs don't like high ORP water at all.
And it also is a great tool for managing your chlorine levels in the pool too.
Yeah, absolutely.
I think one of the worst things that we have for the water quality in our pools is the old practice of dosing a week's worth of chemicals by hand and then walking away and not checking it for another week. a perfect recipe for creating chloramines, chlorine byproducts, and you really have a little sweet spot in the middle of the week, maybe where the chlorine's just right, but the rest of the time there's either too much or too little in the pool if people are swimming. And so an ORP system is a great way to keep the water chemistry level. But then with ozone, the hardest thing about ozone is to quantify it. How much of it do I actually have in the water? What's it really doing? So the ORP is an important tool for that.
Yeah, and deploying the ozone where you have a specific goal for it. So if you go into, let's say you're in the design phase of the pool and the client says, I hate the smell of chlorine. You go, I get it. But chlorine is your signature of safety. But with that said, we want to get as little chlorine as possible for a host of reasons. One, the environmental impact, the production, transportation, and storage of chlorine is highly deleterious to the environment. Number two, we want to minimize bather exposure to chlorine, which is an oxidant, which has an effect on the hair, the skin, the mucous membranes of the body. And then number three, we want to minimize wherever possible those disinfection byproducts that cause bather irritation and are potential carcinogens. And then we also want to eliminate that big elephant in the room, which is chlorine-resistant bacteria. And chlorine-resistant bacteria thrive in what's called a polysaccharide matrix. That's the big word of the day, polysaccharide matrix. And that's basically snot. So if you think about your teeth and you rub your tongue across your teeth, if it's been a while since you brushed your teeth, they get a little furry.
Yep.
That's a polysaccharide matrix. That's a biofilm. And biofilms will form on the sides of pools. We often call them algae. It's not always algae, but it's this slimy coating, and it forms inside plumbing. And that is highly resistant to chlorine. And that's one of the places where ozone can help us, because ozone breaks down organics better than chlorine does. And the disinfection byproducts are non-halide byproducts. So if we think of disinfection byproducts of chlorine, we call them THMs, trihalomethanes. And that halo comes from the halide, chlorine, iodine, fluorine, things like that. With ozone, we don't have that halide component, and the data suggests that there's little or no carcinogenity to those byproducts. So by ozonating, in addition to a good continuous chlorine program, you can end up with a cleaner, safer, healthier water for the bather, because you hit on something big. A lot of pool operators, for a number of different reasons, will dump a bunch of chlorine in once a week. That's like brushing your teeth for an hour on Sunday and deciding you're good for the rest of the week. I mean, that's just not good practice. And so small, consistent dosages are the key, because bacteria grows in small, consistent dosages. Bacteria doesn't wait until Saturday night and then dive in and contaminate your pool. Bacteria slowly grows consistently, 24 hours a day. Bacteria likes dark, bacteria likes warm, bacteria likes organic food. Well, what do we do in a pool? It's dark at least 8 to 10 hours of the day. It's warm 24 hours out of the day. And because us filthy, dirty, disgusting humans get in the pool, we provide a massive amount of organic food for bugs. And it's a recipe for disaster. And that's why a good, properly educated pool professional is the difference between comfort and discomfort, and safety and sickness for that homeowner or that commercial user.
So on the biofilm, ozone, does it actually help kind of break down that matrix that the biofilm lives in?
Yes, ozone really helps to break it down. So if you think about the times you've sniffed ozone or smelled it, it bites you in the nose. You know, it's immediately repulsive. It's disturbing, the amount of force it hits you with, as much or more so than chlorine does. And that's the ozone starting to attack the mucus in the mucosa in your nose and sinuses. And so that it really helps with the organics. It destabilizes the organics. So that volatile extra oxygen, it wants to bond to the organics that make up that biofilm. And so it'll start just attacking it and chewing on it. And that's one of the places where professionals get in trouble when they dose ozone, is they've been told, well, you just need 1 gram an hour, or you need 2 grams an hour, or 5 grams an hour. And honestly, it's difficult to predict what you need. There are actual calculations. You need so many milligrams of ozone to oxidize so much iron. You need so many milligrams of ozone to oxidize so much manganese, hydrogen sulfide. And then there's math for other organic compounds. And this is what we do when we're at the more technical wastewater level, for example. You know, we look at the total organic load and we go, okay, our load is X. We need this much ozone. We have this much contact time. So we need this many grams per hour. It's all math. But there's a wild card when it comes to the pool. The first thing is ozone and chlorine are mutually exclusive. When you ozonate, the ozone reacts with the chlorine. And so you'll actually end up catalyzing chlorine down to chloride. And so some of your ozone will be used up there. Then we've got heat as a factor, and we've got to make sure that we're looking at that very short contact time. And then we don't really know what the organic load is in a pool at any given time, because the cost for a total organic carbon test is prohibitively expensive for the typical recreational pool operator. So you have to guess to get yourself into the ballpark, take your best guess, and then look at actually running your ozone and seeing. And you can do a benchtop test. You take some of the water, bubble the ozone in, you're using an air stone, and then you can use your RP tester to see how it's doing. And you start developing kind of a feel for how it's going. Now, if you have a good ozone vendor, they'll guide you down these roads. And I've never had anybody complain that they had too much ozone, because it's easy. If you have more than you really need, you just dial it down. But we sure do hear a lot of complaints about not having enough. And when it comes to the business management side of it, when you're discussing your pool design with your disinfection strategy with your prospective client, once you've sold them on the concept, they don't like you coming back in a month going, Dave, I'm real sorry, but I miscalculated the ozone. I need you to spend X more $1,000 because we need to buy another ozone generator. They want that pain once. They want that heartburn once. And so it's important that we size it properly and err on the size of caution. Oversize, because it's easy to dial it down. Oversized ozonation equipment will last longer than undersized ozonation equipment, especially on the pre-treat side. Always oversize your air dryer, always oversize your oxygen concentrator. And then be very careful on your Venturi injector or your static mixer. You don't want to create restrictions that cause higher head against your pump, because your pump is dialed in for a particular flow rate. And you don't want to then be causing your pump to wear out faster.
And a Mozzie injector by its nature is going to create some back pressure. It is.
Yeah, significant. Yeah, for sure.
A lot of times what we'll do is we'll add run it in a side stream loop, and we'll just run a smaller pump to supply the Mozzie just enough, but put it right back into the main line so that we end up ozonating all the water in the pool. But we're
that really is a smart way to go. And you're basically side streaming the side stream, because you think of a pool filter, it's a side stream filter, and then you're side streaming the side stream. So it works. You just got to, again, look at your timing, which I'm sure you do. Make sure you have sufficient ozone concentration for the amount of times you're going to recirc in the day.
Right. You broke up on me. I missed when you were starting to talk about the not being able to test the water accurately for the amount of load that's already in there, and that's a problem with a chlorine pool. If you come on a Monday morning after a heavy use weekend and the pool's green, how much of your chlorine is going to get used up just bringing the pool back to zero? How do you know that?
Right.
Absolutely. And then the byproducts of that algae kill. You know, we sometimes think magically when it comes to chemistry. We go, okay, I got a green pool, let me add chlorine and it'll make the algae disappear. No, those algal bodies are still there and they're still contributing to the total organic load. They're just dead and they're bleached, but they're still there. And that's where you got to have good filtration to try and remove those bodies. Interestingly enough, that's where ozone actually helps you out. Ozone when the oxidative effect occurs, it's somewhat of a coagulant. It changes the electric charge of some of these organic molecules, and it makes them stickier, and they tend to clump together and drop out more easily. So you don't need to use as much flock when you're trying to clarify the pool. And it's a lot easier.
That's one of the properties of ozone that I'm really fond of in high-end residential pools, is just that the water clarity and brilliance of an ozone pool is unmatched any other way. Even with a cartridge filter, nothing special in terms of filtration, you can get absolutely brilliant, stellar water quality because of that property of ozone.
I agree. Yeah, it's remarkable. It's brilliant is a good choice of words. That visual clarity, because when you're filtering a pool, you're trying to get as clean as you possibly can, but you've got a lot of things working against you. One of them is pH. Especially if you're using stabilized chlorine. You're doing a lot of things that are adding haze creation. Mm-hmm. And so if you're able to kill and clean organics with zero byproducts, because you're putting a gas in, there's no solids, there's no significant pH effect of the ozone, high or low. You're just minimizing the complexity of the chemistry, especially on an outdoor pool or a pool that's exposed to sunlight, something where you've got a lot of evaporation. Now you've got makeup water coming in, which changes your chemistry over time. You got a lot of factors that affect that clarity. And so having ozone in that toolbox is really going to help.
And I've got a lot of pools where the customer has spent upwards of $150,000 on an all glass tile pool, and there's no way to make it really shine and show off that investment like an ozone system.
I couldn't agree more.
Yeah, that's another point you brought up. Is ozone sensitive to pH?
The ozone itself is pretty stable across typical pHs you're going to see in a pool. So anywhere from 6.0 to 8.0, it's pretty consistent, but the chemical reactions between the ozone and the things that it's reacting with are different. So metals will oxidize faster at higher pHs. Iron, for example, it's a factor of 10 when you go from 6.5 to 7.5. It's a significant difference. And then some organics oxidize better at lower pHs, some at higher pHs. So we try to always advise keeping a relatively neutral pH. For pool maintenance, you don't want to be too acidic, obviously, because your chlorine is getting out of solution too fast, and we're contributing to potential corrosion on plaster and things like that. But then you don't want to run too alkaline either, because you then run the issue of what's called precipitant haze, which is where that pH is rising, and we're basically precipitating, snowing minerals out of the water. And if you've got makeup water that's hard water, when you lose water through evaporation, it's pure water that's leaving. And if you're making up with anything but pure water, you're concentrating and potentiating your mineral load in your water, which then resists the ability for ozone and chlorine to do their job. It's one of the biggest complicating factors you see on outdoor pools.
When you talk about the placement of the ozone system in the pool equipment chain, I have found that ozone is merciless in destroying DE grids, certain types of filter cartridges that will actually turn them into mushy toilet paper. How about pool heater cores? How does ozone react with copper?
So ozone and copper are not friends. Ozone and stainless are buddies. Ozone and copper nickel are buddies. Ozone and copper, not so much. There will be a damaging effect if you inject before the heater. Okay. I always like to advise people, make ozone the last stop. Yeah. Let it get out into the plumbing at the tail end. Or if you're really careful with how you dose it, and you're dosing it up front, but you know that it's going to be destroyed completely before it hits anything else, that's okay. but it's very difficult to be sure that it's going to be destroyed. I'd rather let it go out into the pool and it lives for just a little bit and then it stabilizes back down to air, oxygen. Then you've got less chance of damage to your infrastructure.
That's my preference too. I think a bit of dissolved ozone in the pool is a wonderful thing. I think it's something to shoot for when
I agree 100%. And in low concentrations, ozone has a fresh smell. Obviously, there are NIOSH issues with high concentration ozone. You don't want to be running. It's kind of like deodorizing a room. You don't want to sit in the room while the ozone generator is getting rid of the cigar smoke smell. But if it does the job and then you walk in the room, it's great. And in an indoor pool, just the teeniest, tiniest hint of ozone in the air makes things smell clean, and it eliminates a lot of the issues. You have a side benefit of less algae activity. I don't know if you've noticed on the pools you do, you have less slime buildup on the tiles. You end up with less mustiness in the pool room because that little bit of ozone is enough to inactivate the various other fungus and yeast and mold and things that show up in places like that.
What would you say to putting maybe a little UV unit between ahead of the heater to protect it if you do use a big ozone system?
So let's talk about ozone and UV. So earlier we talked about how we use UV to generate ozone. What Dave's talking about here is different than a UV-based ozone generator. So ozone in the 185 nanometer wavelength creates ozone. Ultraviolet in the 254 nanometer wavelength destroys ozone. And our typical disinfection UV assemblies are 254 nanometer. That's where we have the most beneficial effect on inactivating the DNA of bacteria. It also does a great job of knocking ozone down to nothing. In fact, that's how we generate AOP radicals when we're playing with ozone and UV. So putting UV right after the ozone will generate AOP radicals that are alive for 1/10 of a second. And then it reverts back down to the raw constituent, which is air. And it's great. It would knock that ozone down to nothing really fast.
Okay. Now, UV and AOP is another set of topics, and each one has its own complexities. I would love to have you back at some point in time to maybe get into each one of those a little bit, if you'd be up for that.
Oh, absolutely. And they're, like so many things, they're often oversold and misunderstood. And so somebody might have a preconceived notion based on a really bad experience that wasn't necessarily the fault of the technology. But like any tool, you have to understand the strengths and weaknesses and know when it's going to be a good choice and when it's not necessarily going to be a good choice. And no one tool works best for everything. It's like chlorine. Chlorine isn't always the best disinfectant. Neither is ozone, neither is ultraviolet. Each tool has its place.
Right. And I think that's I would like that to be the takeaway from our conversation. If you go to your normal, back when we had them, pool trade shows.
Right.
There are classes, the Western Pool and Spa Show last year had something like 15 to 20 different classes on aspects of chlorine chemistry. And so everybody's aware that it's not that simple. There's a lot to it. Well, this is the same thing. The other tools that you have, ozone, AOP, UV, it's not just a matter of spending a few $1,000s and tacking something on the wall and attaching it to the plumbing, and all of a sudden your pool problems are going to go away. There's a complexity to each one of these things, and it's the professional who's going to have the greatest success with them is one who takes the time to learn the strengths and weaknesses of each one and where to use it at the right time.
Right.
I agree 100%. And that, I think, speaks to where the pool professional industry is going. Yes. The days of the person who shows up in their shorts with a skimmer and a bucket of chlorine are gone. Thank goodness for that.
I don't know, Greg. I don't know.
Because
we're
there's
trying to
so much more to it. I mean, we have to take a scientific approach to it, and it's abusive to customers to just throw chlorine in. I mean, think about the cellular damage you're doing to their kids. Somebody buys a pool so their kids can have fun, and then you're slowly poisoning them and causing cancer in them. So when they're 80 years old and they're riddled with cancer, it was you, pool guy, you did that. We don't want to be those people. As professionals, we want to give a better experience for that homeowner or that commercial user. And the smarter you are, the better job you're going to do. So education,
absolutely, in every industry, not just this one, every industry. Yes.
Yeah. Take the time to read, take time to study. And I mean, you look at like this podcast, you can listen to this podcast while you're driving to the next pool job and looking at your skimmer, your shorts, and your bucket and chlorine, and kind of rethink your place in the world.
Yeah.
The whole point of this podcast, Greg, that's why we started it, was to help. Because, you know, Dave, I think he's on the upper echelon of the pool service guys in that he loves information. He wants to learn more. He goes out there and reads articles and does everything. And that's Dave's MO. And I think the whole point of this podcast is to really introduce the higher level topics to pool service pros and hope that they will listen and learn something from it. And maybe we call it elevating the industry and it not just being what you described earlier. That's really the point here.
Yeah, you're wise. And the rising tide raises all boats. I mean, the smarter you are, the smarter your peers are, the better the industry does. And at the end of the day, especially in California, you want to do as much as you can to minimize regulatory interference. And the way to do that is to do a better, smarter, cleaner, more environmentally friendly job.
not have the problem there in the first place for them to have to regulate it away.
Exactly.
Absolutely.
Exactly. And the best way to be is to be self-policing. And that's the beauty of the competitive marketplace. If Dave's out there being smart and people are willing to pay money to have Dave take care of their pools, the next guy is going to go, maybe I can do that. And then the next woman's going to go, maybe I can do that. And I like that way of moving forward in business, because we're all doing better because we want to. We're not being forced to by government.
Yes.
And we have a more educated consumer nowadays, and it's absolutely shameful if the consumer knows more about water chemistry than the person they're paying to do their pool.
Right. Yeah, that is sad. And there's so much knowledge available out there. You know, your association provides a lot of training, and, you know, even associations like ours, the Water Quality Association or the Pacific Water Quality Association, we're always happy to engage with anybody who's in an industry related to water quality and guide and give any help that we can, because we all get through this better together. And smart education is what helps us all progress our industries forward.
And if you want to learn some more too, just in regards to water chemistry, or water quality in general, Greg has a website called GregKnowsWater.com, where he has a lot of blogs and lots of information and resources out there. So if you have an additional interest in just learning about water quality in general, outside of the pool industry or within, he has lots of blogs and articles out there on his website that you can access and read. And I think that's the whole point of you listening to this podcast, is that you're obviously already interested in learning, because otherwise you wouldn't be listening in the first place. So maybe that's a good place for you to get some additional information.
And that's how we found him, and we're glad.
It is, yes. I don't know where I saw your article from 2016 that was in WCP, but I don't know how I came across it, Greg. I'm not exactly sure, but I read it, and then I sent it to Dave. I'm like, we should get this guy on the podcast. And he goes, yes, please do.
Well, interestingly enough, ozone is one of my specialties. And so there've been a few articles out there and a lot of interviews. And unfortunately, one of my ozone articles has been quoted a lot by a certain ozone manufacturer who sells in California to pool and spa operators. And I had to have a word with them, because they were taking a lot out of context and promoting their product at the expense of the science. And that's, at the end of the day, my intent here is really simple. I want everybody to be smart. I want everyone to know how to do the job right, how to make sure they're protecting their customer, and how to protect themselves from liability, not promoting one product over another.
Right. You can spin anything depending on the story you want to tell.
Exactly.
So be careful. And I say that in all areas, I'm not going to get involved in anything, other conversations, but in all areas, you can spin anything the way you want to, depending on what story you're trying to tell.
Yeah,
We're running low on time here, but for Greg, but I had one question that I wanted to ask earlier, and it slipped my mind. But I'd like to get your response to one thing. In the pool service industry and talking with our customers, we hear one thing a lot. A customer comes to us and says, "I'm allergic to chlorine. I have to get chlorine out of my pool because I'm allergic to it." What are your thoughts on that?
Yeah, wow, that's a long discussion. So the first thing is always to try to understand what that means. It's kind of like when people say they're allergic to gluten. Well, what does that mean? Does that mean if you eat wheat, you gain weight? Does that mean if you eat wheat, you get an upset stomach? Or does it mean you're a celiac and your very life is at risk if you eat wheat? So when someone says, I'm allergic to chlorine, a good immediate thing to say is, well, how do you mean? Help me understand. Because we don't want to make any assumptions, because I'm allergic to chlorine might really mean I hate the way chlorine makes my eyes feel.
Yep.
Or I hate the way chlorine smells. Or when I smelled chlorine at the pool when I was in the Navy and it stank like old feet, I was nauseous. I must be allergic to chlorine. Or, so we need to quantify what that client is trying to tell us. So when it comes to allergens and the body's immune system, chlorine in and of itself, Cl, is neither allergenic nor hypoallergenic. It's completely outside of the realm. It's not an organic compound. It's a highly volatile gas. When it reacts with your immune system, it just breaks it. It's not like gluten or something like that that's going to cause an inflammatory response. Chlorine just attacks. And so what hurts our eyes when we swim, when we're in a pool that doesn't have good balanced chlorinated water, because properly balanced chlorinated water with very few chloramines and disinfection byproducts does not hurt the eyes much at all. When you get burny eyes coming out of a pool, that's a really good indication that you're out of balance chemically and you have an organic overload, and there's a lot of disinfection byproducts that really should have been addressed. And so we go back to, what does that mean? Well, it means when I get in a chlorinated pool, I get a rash. Okay. Now we've got something to talk about. Well, what causes rashes? Chlorine in and of itself is not going to cause a rash, but it can exacerbate existing conditions. So eczema, psoriasis, dry skin, those are immune system conditions. And the medical industry spends hundreds of billions of dollars a year trying to correct those immunosystem deficiencies or over-excitable immune systems. Chlorine makes it worse. So if somebody has psoriasis and they get in a pool, it's going to inflame that psoriatic scale. If somebody has dandruff, it might inflame that dandruff so that their dandruff is worse when they dry their hair after they've been in the pool. Now, does that mean they're allergic to chlorine? Well, not really, but it is something that makes their life unpleasant.
Yeah.
And so that's where we got to be careful, because I'm not a doctor, I'm just an engineer. And as a pool professional, you're not a doctor unless you're moonlighting between time at the ER. You got to be really careful that we don't get into trying to make medical prescriptions or medical pronouncements. And we certainly don't want to go down the path that I saw people go down years ago, where they go, okay, it's not a chlorine pool, it's a saltwater pool. And that's healthy and it'll cure your eczema. No, let's not do that. And so somebody says, I'm allergic to chlorine. What do you mean? Let's try to understand it. And then let's look at what we can do to help mitigate it. Have you ever bathed in a pool where it didn't hurt your skin? Yes, I was on vacation in the Bahamas. It was a saltwater pool. Okay. Well, saltwater pools are chlorine pools. Don't let anybody tell you they're not.
That's right.
But it's a different way of chlorinating, and we've got other compounds in the water, and we're chlorinating at a lower level. And the saltwater pool, what makes it so appealing is low consistent doses. And that might be where ozone with an ORP and then supplemental chlorine could be beneficial, because you're going to minimize that organic load and you're going to minimize the peaks of chlorine and the peaks of chlorine disinfection byproducts. So it's a long discussion, and it's really a philosophy thing. Yeah. Understand what your client's telling you.
That was a great answer.
That was a great answer. Thank you for that, Greg. I love it.
That's exactly what I wanted to
touch on.
Yeah. Greg, thank you so much for your time. This has been a great conversation. We'd love to have you back to further discussion on non-chlorine solutions or additional solutions to chlorine in the pool. We really appreciate your time, and hope we'll see you again.
My pleasure, Dave. It's always great to engage with other professionals who care about their customers and about doing their job better. Keep up the good work. You guys are doing great.
And stay tuned for future episodes as well, because Dave is going to talk about secondary sanitation systems with lots of different experts, including himself, because he is an expert in this area also. So we'll have episodes coming up where we'll talk about these types of things and hope to educate you further on better ways to have good water quality. Thank you.
Thanks, Greg.
Nicely done. Thanks, guys. Talk to you later.
A new voice in the industry, a resource for all, education for you. This is Pool Pro Podcast. Build relationships and share important news as we get ready for our next backyard adventure. Pool Pro Podcast. Backyard adventures are better together. Please take a moment to share, like, and review our content with all of those that would be interested.